An emerald green object is racing past Mars tonight, but is 3I/Atlas just a bizarre comet or something far more unusual? That single question hangs over every control room in the solar system. For 6 hours only, Mars becomes our lone vantage point. Earth's instruments fall blind behind the sun, leaving a handful of orbiters and rovers to capture the truth. Already, Atlas has broken the rules. Rhythmic pulses of light, strange accelerations, and chemistry unlike any comet we've ever seen. Each clue deepens the puzzle. Natural outlier or a sign of engineering. This encounter is more than a spectacle. It's a test of science itself and of how we respond when the universe hands us questions without easy answers. Love big cosmic mysteries told as they unfold? Subscribe now so you don't miss the revelations that follow. The 6-hour blackout. As 3I/Atlas brushes past Mars, a rare alignment silences Earth's observatories. It isn't a failure of planning or a glitch in technology, it's geometry. For 6 crucial hours, the sun blocks our line of sight, and Mars becomes the only observatory in the solar system. Every orbiter above the red planet pivots into high-cadence observation. MAVEN, Mars Express, and ExoMars Trace Gas Orbiter prepare to capture every flicker of light and every spectral oddity. Timing is ruthless. Imaging cycles, spectrometer sweeps, and particle measurements are scheduled down to the minute. A single misstep could mean losing evidence that will never return. In these hours, every byte of data could change how we understand interstellar visitors. The Red Watch Coalition. Inside MAVEN's control center, a special team known as the Red Watch takes command. These operators are trained for anomalies, running decision ladders for every possible scenario, from sudden dust bursts to unexplained flares. Redundancy is the rule. Backup commands are preloaded, cross-checks run with Mars Express and TGO, and every data packet is copied twice before transmission. Even amateurs join the watch. Backyard telescopes and robotic arrays across Earth record what they can, feeding real-time photometry into global databases. For 6 hours, the solar system's attention funnels through Mars, while citizen scientists stand shoulder to shoulder with professional teams. The atmosphere in the control rooms is tense, almost surgical. Clocks tick down to Atlas's closest pass, while operators balance science with survival, ready to shift instruments into safe mode if a debris cloud surges too close. Every second is a turning point. The solar system is blind except for Mars, and the stakes could not be higher. First, discoveries. The mystery began not in a professional lab, but in a backyard observatory in Pune, India. Citizen astronomer Priya Ralo noticed something odd in the light curve of 3I/Atlas. A repeating pulse, brightening and dimming with a rhythm that no comet textbook could explain. When larger observatories pointed their arrays at the object, they confirmed her suspicion. The pulses were real, sharp, regular, and strangely consistent, as if switched on and off by some hidden hand. Chemical surprises. The closer Atlas came, the stranger its chemistry appeared. Spectrometers revealed almost no water vapor, the usual signature of a comet. Instead, carbon dioxide dominated at an astonishing ratio of 8:1 compared to water, an order of magnitude higher than even the most volatile rich comets in our solar system. And then there was the color. Atlas's coma blazed emerald green, a hue peaking at 516 nanometers. Normally, such a glow comes from fleeting molecules like C2, but here the intensity and stability defied every model. Even stranger, nickel emission lines outshone iron by factors of 4:1, a complete reversal of what has ever been recorded in solar system comets. Physical anomalies. If the chemistry was unsettling, the physics was downright bizarre. Atlas shed dust unlike any comet seen before. Large, slow-moving grains that drifted in broad arcs instead of streaming chaotically behind. Polarization data added another twist, showing a negative polarization branch, a feature more typical of asteroids than of icy wanderers. Then came the accelerations. Precision tracking revealed tiny but deliberate-looking nudges in its course, each one coinciding with a brightness pulse. Natural outgassing can push a comet around, but never in such synchronized bursts. Together, these anomalies painted a picture that refused to fit into any single category. Individually, each signal might have been explained away as rare chance or odd chemistry, but together they suggested something else entirely, that Atlas was not just another interstellar fragment, but a phenomenon that could stretch the boundaries of science, or possibly hint at something engineered. 4 scientific explanations. When confronted with anomalies, science always begins with the simplest possible answers. For 3I/Atlas, researchers tested 4 main hypotheses, each grounded in known physics and chemistry, each stretched to its limits by the evidence. 1. Extreme formation conditions. Perhaps Atlas formed in the coldest, most distant reaches of interstellar space, where even water freezes out, and only rarer ices like carbon dioxide and carbon monoxide survive. In this scenario, the 8:1 CO2 to water ratio might be extreme but not impossible. With such a tiny sample of interstellar visitors, only 2 before Atlas, an outlier could simply redefine what's possible in comet chemistry. 2. Internal structures and trapped gases. Another theory points inward. Atlas could contain volatile pockets buried deep inside, reservoirs of gas that erupt as sunlight penetrates the crust. If these layers were distributed unevenly, they might explain the regular pulses of brightness seen from Earth and Mars. Laboratory simulations show that stratified ices can produce repeating outbursts, though never as cleanly timed as Atlas's mysterious rhythm. 3. Unusual dust dynamics. The strange dust trails and emerald glow might stem from composition rather than chemistry. Atlas releases larger, slower grains than any comet on record, grains that drift in wide arcs instead of chaotic jets. Solar wind and magnetic fields could be shepherding them into patterns that mimic deliberate bursts. The polarization data, asteroid-like rather than comet-like, strengthens this possibility, suggesting compact, carbon-rich dust rather than the fluffy ice grains we expect. 4. Limits of our models. Finally, some scientists argue that Atlas is a mirror showing us the edges of our own ignorance. With only 3 interstellar visitors known, our models may simply be inadequate. The synchronized pulses and microaccelerations could be subtle interactions between sunlight, tumbling motion, and volatile release, a kind of physics we haven't yet fully captured in our equations. Individually, each explanation seems plausible, yet none fully accounts for every signal: the chemistry, the pulses, the dust, and the accelerations, which means the question remains wide open. Is 3I/Atlas a natural outlier, or something that defies natural categories altogether? To answer the question posed at the beginning, is 3I/Atlas just a bizarre comet or something more unusual? The only path forward is data, and for 6 critical hours, Mars was the solar system's only laboratory. Every eye, every sensor, every probe had to turn upward and capture what Earth could not see. MAVEN. NASA's MAVEN orbiter became the spearhead of this effort. Its ultraviolet spectrograph swept through Atlas's glowing tail, searching for faint emissions that could betray fragmentation or exotic chemistry. Meanwhile, MAVEN's particle counters and magnetometers monitored Mars's ionosphere for ripples, subtle disturbances that might reveal an unnatural interaction between the object and its environment. Mars Express. ESA's Mars Express contributed a different perspective. Its cameras stacked rapid-fire broadband images of Atlas's coma, hunting for sudden splits or course changes. Its spectrometer scanned from ultraviolet to infrared, flagging spectral lines that didn't belong, while its plasma analyzer tracked energetic ions that could hint at non-standard activity. ExoMars TGO. The trace gas orbiter pushed deeper into the chemistry. Its instruments probed Atlas's coma for isotopic ratios and unusual molecular fingerprints, while its high-resolution imager tried to catch jets or fragmentation events in real time. Rovers on the ground. Even the surface joined the effort. NASA's Perseverance and China's Zhurong rovers kept watch for indirect effects, faint auroras, unusual dust fallout, or atmospheric shifts that might ripple down from Atlas's passage overhead. Together, this flotilla of instruments formed a single system, each probe checking the others, each reading cross-verified. No single anomaly would be enough. Only if multiple independent signals aligned could scientists take a step closer to the truth. And as Atlas passed, those signals began to pour in. Collecting data was only the first step. To turn observations into answers, the teams on Mars followed a strict protocol, one designed to separate rare natural phenomena from anything truly extraordinary. Redundancy was the first safeguard. Every data packet relayed from MAVEN, Mars Express, and TGO was duplicated, timestamped, and logged independently by multiple ground stations. This ensured that solar interference, transmission errors, or corrupted files couldn't compromise the record. When an anomaly was flagged, a strange spectral line, a sudden flare, or a shift in trajectory, at least 2 instruments had to confirm it before it moved forward. No single reading was ever enough. Planetary protection rules added another layer. If physical particles were detected, dust or ice grains, they were tagged, sealed, and logged with digital hashes to preserve chain of custody. Nothing could be mistaken for Martian contamination or mishandled evidence. Finally came the decision matrix, the heart of the process. Every anomaly was classified into one of 3 paths. Conservative, a rare but natural comet behavior. Hazardous, fragmentation or debris that endangered the orbiters. Extraordinary, at least 2 independent anomalies pointing beyond known physics or chemistry. Only converging evidence across multiple systems could justify moving into the extraordinary branch. And with 3I/Atlas, convergence was exactly what the world was waiting for. The flyby of 3I/Atlas didn't just challenge science, it reshaped how science is done. For the first time, raw interstellar data flowed openly to the public within hours, not months. NASA, ESA, and JAXA coordinated mirrored archives, releasing both calibrated and raw readings so researchers and citizen scientists alike could dive in. The age of embargoed comet data was over. Citizen science itself became central, not peripheral. Amateur astronomers from Pune to Patagonia fed their light curves directly into vetted pipelines, where machine learning systems flagged promising signals for professional review. Backyard observations could now trigger global alerts within minutes, proving that discovery is no longer limited to official missions. Planetary protection protocols were also rewritten, requiring strict chain of custody logs for every potential biosignature or dust fragment. Atlas wasn't just an interstellar visitor. It became the template for how humanity will confront future messengers from beyond the sun. On October 3, 2025, 3I/Atlas swept past Mars at just 0.19 astronomical units, and for 6 tense hours, the red planet became the hub of the solar system. MAVEN, Mars Express, and the Trace Gas Orbiter returned more than 40 hours of high-cadence data, spectra, images, and particle counts, capturing the emerald glow, synchronized pulses, and carbon dioxide-rich chemistry that defied easy explanation. Some mysteries remain unresolved. The microaccelerations matched to brightness pulses have no clear natural cause. The strange spectral lines still lack a definitive model. Whether Atlas was simply the rarest of comets or a sign of something engineered remains an open question. What is certain is its legacy. Atlas has changed how science prepares for interstellar encounters. Transparency, speed, and global collaboration are now the standard. The solar system may be vast, but when visitors arrive from beyond, humanity will meet them together. If you've enjoyed following this journey into the unknown, don't forget to like, share, and subscribe so you're here for the next mystery from beyond the stars.